Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak and this is Daily Quant with Deepak. Hello all, welcome to day 20. In this video, we'll be discussing 5 questions from PNC and probability. So whenever a question is being displayed on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. Coming to the first question, 5 men and 6 women have to be seated in a straight row so that no 2 women are together. So there is a condition on women. There is no condition on men. So what we'll do is we'll first try placing 5 men. 3, 4, 5. So in how many ways can we arrange 5 men in these 5 places? 5 factorial ways. So we are done with arrangement of men. Now find the number of ways this can be done. Now after placing 5 men, how many places do we get to place women? You have 1, 2, 3, 4, 5, 6. So after placing 5 men, we have got 6 places, and in these 6 places, we need to accommodate 6 women. In how many ways can that be done? 6 factorial ways. So 5 factorial into 6 factorial. 86,400 should be the answer for this question. Now coming to the second question. The number of different ways in which 8 persons can stand in a row so that between 2 particular persons A and B there are always 2 persons, right? So we have two people A and B. Now you need to always have exactly 2 persons sitting between A and B. So that could be this arrangement or this, right? So from 8 there are 2 people A and B, and you need to have exactly 2 persons sitting between these 2 people. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, now let me consider these 4 to be one unit, right? So you can have A and B here or B and A. Now our job is to select 2 persons, right? In how many ways can that be done? So we have in total 1, 2, 3, 4, 5, 6. From 6 you need to select 2. So that could be done in 6C2 ways, right? Now after selection you also need to arrange them in these 2 places into 2 factorial, right? Now we have how many? 1, 2, 3, 4, 5, right? So they can be arranged in how many ways? 5 factorial. Now this is for BA and 4 places. Similarly, you will have the same number of cases when you have A and B sitting at these 2 places. So into 2. Now what is 6C2? 6 factorial by 4 factorial into 2 factorial into 2 factorial into 5 factorial into 2 factorial. I can cancel these 2. Now 4 factorial by 6 factorial. This is nothing but 5 into 6, right? Now 5 into 6, 30, 30 into 2, 60. So 60 into 5 factorial should be the answer for this question. Hence option A. Now coming to the third question. The total number of 8-digit numbers in which all digits are different. So we have how many? 1, 2, 3, 4, 5, 6, 7, 8. 8-digit numbers, right? All the digits should be different. So that means there should not be any repetition of the digits. Now how many digits do we have? From 0 to 9, you have 10 digits. Now coming to this digit, the leftmost digit. Now can this be 0? No, this cannot be 0, right? So you have how many ways of selecting this digit? You have 9 ways, right? Now once you have selected this digit, we are left with 9 more digits because now you can include 0, right? So you can select this in 9 ways: 8, 7, 6, 5, 4 into 3, right? Now what I'll do is I'll multiply this with 2 into 1 and I'll divide with 2 as well. Now what is 9 into 8 into so on till 1? 9 factorial. So we have 9 factorial by 2 into 9. So 9 into 9 factorial by 2. Option B should be the answer for this question. Now coming to the fourth question. In how many ways can the letters of the word valedictory? So VALEDICTORY Why? Be arranged so that the vowels are never separated. So vowels should be together. Now what are the vowels? A, E, I and O. So A, E, I and O. Right? And we are left with the consonants. So V, L, D, C, T, R and Y. Now, are there any repetitions? No, right? So they have to be together. So we need to consider this as one unit. So how many units do we have? 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 factorial into. Now we are done with the outer arrangement. We should also include inner arrangement. That means rearrangement of these four vowels among themselves. So into 4 factorial, right? So the answer for this question should be 8 factorial into 4 factorial. Now coming to the fifth question. A problem of mathematics is given to 3 students A, B and C whose chances of solving it are 1 by 2, 1 by 3 and 1 by 4 respectively. So we have 3 students A, B, C. The probability of A solving that problem is 1 by 2. Probability of B solving the problem is 1 by 3 and C 1 by 4. Right. Then find the probability that the problem will be solved. Now here I want you guys to understand that if the problem is solved, it would have been solved by A or B or C or A and B or B and C or A and C or all A, B and C together. Right. So the best way to answer this question is, now given with the probability of these 3 persons solving that, let's find the probability of non-occurrence of that event. Right. What is the probability of A not solving that problem? 1 minus 1 by 2. 1 by 2. Now, if the probability of B solving that problem is 1 by 3, B not solving that problem is 2 by 3. The probability of C solving the problem is 1 by 4. The probability of C not solving the problem would be 3 by 4. Now let's find the probability of the problem not being solved. Right. That means A, B and C, they did not solve the problem. So 1 by 2 into 2 by 3 into 3 by 4. So I can cancel these two. I can cancel these two. So the probability of the problem not being solved is 1 by 4. If the probability of the problem not being solved is 1 by 4, the probability of the problem being solved is 1 minus 1 by 4. 3 by 4 should be the answer for this question.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share and subscribe.